Hey, seventh grade. So today we are going to be looking at how to set up and solve proportions. And we did this a little bit earlier this year, but we're going to do it again because this is really what similar figures is all about, proportions. So this document is shared with you, and there are examples here that whenever you open this document, you will see all of it worked out because that's what we're doing right now. And then your assignment is going to be, I don't even know. Your assignment is going to be these four problems down here. And I am going to be using the equation editor so that I can type my work in, and I'm going to show you how to get to that. You don't have to use the equation editor. You can take a picture of your handwritten work and then submit that along with the assignment in the portal, and that'll be just fine. But let's get started here. So we want to set up and solve a proportion for each scenario and show all work. So the first thing I want to do is get my equation editor, and we want to remember that I'm also going to change the size on this so that I can do a fraction at an appropriate size. We also want to remember what a proportion is, which is a set of fractions, two fractions, that are equivalent to each other. So if you didn't see what I did, I went to Insert, Equation, and then it brought up this bar here, and the math operations, this one is a fraction. So there we go. 6 kilograms of bananas cost $72. How much would 14 kilograms cost? So with these fractions, the denominators have to represent the same thing and the numerators have to represent the same things. So I'm going to make this kilograms. Oh dear, I guess it would help if it were activated. There we go. Kilograms per dollar. You can absolutely set this up upside down. You could make it dollars per kilogram, whatever. That's fine. But pick one and stick to it. So that's going to give us, and back to the fractions, that's going to give us 6 kilograms for $72, and that's going to be the same as, so then equals, and another fraction. And with this, all I'm doing is typing, and then to get to the bottom, instead of clicking on it, I just hit the over button, the right arrow button, and that takes me to the next line. How much would 14 kilograms cost? So I know that it's 14 kilograms. I do not know how much that dollar is, that dollar amount. So there's that. That's my setup. Well, then how I make this work, remember, is we cross multiply, set them equal, and solve. So when I cross multiply, 6 times x is just going to be 6x. Set them equal, so the other side, 72 times 14, you see I brought my calculator up here, 72 times 14, and that's 1008. And then we divide by the number touching x. And so on each side, I'm going to divide by 6. And so that's going to give me, I just like the equation editor for this line. Obviously, there's nothing fancy that you have to do, even on this line right here, nothing fancy. So then we're going to take 1008 and divide it by 6, which is 168. There we go. Dollars. So 14 kilograms would cost $168. 1 kilogram, by the way, is just over 2 pounds, like 2.2 pounds. And so we're thinking that 20 pounds of bananas, I should say 30 pounds of bananas cost $168. When I went to Walmart this morning, bananas were 52 cents a pound. So these must be some insane bananas. And it's funny because bananas means nuts. All right. So if 4 out of 10 people vote, next one. If 4 out of 10 people vote, then in a town with 200,000 people, how many people will vote? Well, let's see. Voters. Okay, so if you don't want to use the equation editor, that's fine. You can go voters over total population. Okay, and you can just use a slash bar like that. That is going to make it a little bit messier, in my opinion. But I mean, you're free to type however you want. So voters for population. Could it be population over voters? Sure. Are we going to end up multiplying the same numbers? Absolutely. Are we going to get the same answer? Yeah. So that's just the setup that first came to my mind. No need to overthink it. All right, so that's going to give us 4 out of 10 people, and so that should be equivalent to, dang it, there we go. Sorry, I was too happy with my mouse there. All right. So in a town with 200,000 people, that's the total population. How many will vote? So how many of them are voters? I don't know. That's my variable. Sorry, that's my variable. And then 200,000 people. All right. And so then that's going to be 10x equals 800,000 people. There we go. That's the right amount of zeros. I guess I could put a comma in there like, you're technically supposed to, I guess, so that we can actually see if this is the right amount. And so then that would be x is 80,000 people. So in a town with 200,000 people, only 80,000 will vote. Okay. Alrighty. So let's go ahead and go to the next one. Sam drove 320 miles in 2.5 hours. Oh no, a decimal. Yeah, you're not scared of decimals. Never mind. I don't know what I'm talking about. All right. So here's the proportion that we're going to set up. I'm going to go miles versus time. Okay, and so that's going to give me, that's going to give, hello, that's going to give me 320 miles in 2.5 hours. And that's going to be equivalent to how long will it take to drive 500 miles at the same rate? Well, I mean, what we're asking for, we know how many miles, so I can type that in, and I don't know how long it will take. That's time. So that's my x value there. All right, so that's 320x equals 500 times 2.5. It's been a long day. I don't feel bad about using the calculator. 1250. There we go. And so then we divide by the number touching x. And so 1250 divided by 320, that's the math that we're going to do, is 3.9. We're going to say about 3.9. So x is 3.9 hours. Ah, I can type. All right, last one. So this one is, let me see if I can blow this picture up just a little bit. This one is about a picture. And I would actually like to make all of this up here just a wee bit smaller so that I can keep it all on the same page. There we go. All right, so what is the length of the unknown side? In all of the other problems, we have had words that tell us, what should go on top, what should go on the bottom to keep it the same. These could go a couple of different ways. What I like to do is see the big side on the triangle here. That matches up with the big side on the triangle here. This side matches up with this side. And so what I'm going to do is I'm going to set up my proportion big side over small side. And that's going to give me 15 over x equals big side on the little triangle, 12 over 6.4. Now, I am going to show you a couple other ways to set this up. We could do everything on the big triangle. So we'll call the big triangle triangle B, and we'll call the little triangle triangle L. Okay. Oh, no wonder. I forgot. Man. Okay. Right. And so that's going to give us, no, that's wrong. 15 is the big side on the big triangle. And that same side, that corresponding side, I guess I should say, on the other triangle is 12. And then the shorter side on triangle B, the big triangle, is X. It's the length that I don't know. And then the short side on triangle L is 6.4. Now, these two are completely different setups, right? But when we cross multiply them, look here, we're still multiplying 15 times 6.4, 15 times 6.4, x times 12, x times 12, 12 times x, whatever, it's the same thing. And so if you keep the sides of the same triangle in the same fraction, that's fine. If you keep the corresponding sides, big side, on the different triangles, pardon me, hiccups. If you keep those corresponding sides in the same fraction, then that's fine too. So there's a couple of different ways that you can set this up, and both of them are valid. Well, both of these that I showed you are valid. A couple others are too. Where it's not good is if you start mixing and matching sides. Okay. It's 10:30, guys. I'm so sorry. My words are coming out of my mouth like jello. It's horrible. So either which way we do this, it's going to be 12x equals, okay, and my typers aren't working either, is 15 times 6.4. So let's see, 15 times 6.4, 96. There we go. Good. 96. I feel like 96 is one of those perfect 12 numbers, but I'm not going to risk it and look like a fool, so I'm going to completely mess everything up. I'm going to check it in the calculator. Yeah, that's 8. So x equals 8. Try not to look like a fool, and there I go, proving that I am one. All right, so those are my examples for you. Hopefully they were clearly enough typed and clearly enough explained. If not, please make sure that you reach out to me, or if there's a person in your household or at your fingertips there on the Google machine that can help you, then please absolutely do. But please know that I am always available to help answer any questions that you have. So your assignment, very similar to the voter question, very similar to the bananas question, very similar to the problem that we just did with the shapes, and almost identical to the car question. Okay, so there's that. You can use the equation editor, like I said, or you can write it out by hand, or you can type it however it makes you happy. But please make sure that you do submit your work along with your homework submission. I'm going to get off of here because I feel like this video is way too long already. So I'll see you guys tomorrow.